The Arduino project provides the first look into communication between devices in the form of solving mathematical equations between the Nano host and the UNO assistant using a wired connection. The required parts of this project are shown on the screen. To show equations and answers, a liquid crystal display, or LCD for short, is used, which consists of a backlight and a number of polarized filters to block the backlight or to let light through when rotated in certain directions by liquid crystals. These filters are present in 5x8 rectangles laid out in a 16x2 formation to display words and mathematical expressions communicated from the Nano to the UNO using UART, which involves wired communication through RX and TX pins of two Arduinos. To establish this communication, the RX pins connects with the opposite TX pins and a common ground is shared. Because there is only one UART channel on the UNO and Nano, primarily used for the serial monitor, the software serial library is implemented into the code to convert digital I/O pins into RX and TX communicators. This allows input from the serial monitor to be read from the Nano and transferred using the converted pins to the UNO where it receives data and computes an answer. Since two Arduinos are used, the code is split into two sketches, one uploaded to the Nano and the other to the UNO. To begin performing calculations, a setup of the LCD screen and UART channel chat is initialized for both the UNO and Nano where both devices wait for incoming data. When input from the serial monitor is present, the Nano reads it and pre-processing occurs to check if the equation is malformed. If it's not syntactically correct, the data isn't sent to the UNO, but if it is, the equation gets relayed through the UART channel. The UNO reads this equation and processes it when data is received, relying on a heavy use of modular programming and functions. First, the position of an operator in the string is found by comparing each string character with operator characters, which splits the equation into separate operands and is then checked for division by 0. Using this method completes the enriched task of allowing multi-digit operands since the operator position acts as a divider separating any length of operands. After separation, the operands and operator is inputted through the solve function, which compares the operator ASCII value and returns the proper equation and answer that is then displayed in decimal on the UNO LCD screen. After 5 seconds of display, the UNO and Nano screens return to waiting for more input. To extend the use of this project, more operators were added, including bitwise operators and a random number generator. Instructions on how to use all operators are shown when starting up the serial monitor. By taking a look at a way of communication between devices, a sort of talking network can be established to process and relay simple arithmetic, opening up the door to more complex projects using different forms of communication. Thanks for watching.